Hey, good afternoon. Thank you everyone for attending. I know it's the last session, so I don't promise to be short, but I have a good demo at the end, so I hope you'll stick around. So my name is Vikram Vaswani. I work with Dagger, and the topic of today's talk is self-healing pipelines. Um, so I'm gonna walk you through a little bit of a history lesson, and then we jump straight into what these are. So I want everyone here to think a little bit about the first time they built a CI pipeline for their project, right? The first you do a git init, you start your project, and you realize, hey, I need some CI. And if you think about it, like your CI pipeline is producing, some kind of deliverable, maybe a binary build, maybe a container, and it's pretty neat when you get started, right? It's just pretty simple, very streamlined. It gets the job done. And then what happens is, as time passes, you start kind of improving your project, you start adding features to it. And so as you add features, obviously you need to add tests. Well, we all should add tests. A lot of us don't, but we should. And then your CI pipeline has to start obviously running those tests as well. And so that simple CI pipeline kind of becomes a little bit more complicated, right? So if you look here, we have day one. Maybe you go a month later, it's doing a little bit more. And then time passes, right? Maybe now it's a year later, and your pipeline is doing a lot more, right? It started off pretty simple. Now it's doing unit tests. Maybe you've added more people to your team. There's more code coming in. There are more edge cases you need to worry about. And so it's doing a lot of different stuff. And so you end up with a very complex pipeline. So if you, and just to kind of illustrate the difference, so if you think of it as a factory, that was your factory on day one, and at the end of it, it's much messier. It's not really easy to understand what's happening in the CI pipeline. And because it's so difficult to understand what's happening, it's also very difficult to maintain it. So if something breaks, it's very hard for a developer to jump in and very easily reproduce that error or fix that error, and even keep improving the pipeline. And so let's ask the question, right? How did we get from that simple, streamlined, very clean, very efficient pipeline to kind of the factory mess that we saw at the end? And there are quite a few patterns that we see. And I want to just ask how many people have seen something like this in their Git logs? Yeah, okay, so it's familiar, right? And you know why this is, right? Because usually, okay, I won't say, well, 8 times out of 10, is it a YAML comma, a YAML tab, YAML spaces, white space, things like that. And you can make out it's a developer getting frustrated, trying to figure out what went wrong. Why does this pipeline run on my machine, but it does not run on GitHub Actions or in my CI, right? And this is a developer trying to fix it. Another problem that happens pretty often is when you're trying to migrate your pipeline, right? And usually what happens is you kind of settle on a CI provider. You say, hey, I want to use GitHub Actions. You invest a lot of time in building your CI pipeline for that provider, but maybe for some reason you want to switch it over, right? And then you have this problem. You have a new pipeline and you have an old pipeline, and you need to make sure that both are working because you've got developers pushing code all the time. So you can't just turn off one, but you're trying to migrate to the second one, and so you kind of have 2 of them running in parallel. And 2 of them running in parallel is also obviously adding complexity. This is kind of, I think the picture on the right says it all, right? It's a very complex CI pipeline. It's hard to debug. It's hard to even understand what's happening in this. And if you can imagine how difficult it would be to find a bug if this pipeline breaks. And of course, another one that we see, and these are kind of just snapshots of very popular open source projects on GitHub. And the problem is that for open source maintainers, they have limited time. And there's a whole lot of PRs that they have to review. Very often they don't have the resources to do it. And of course, now we have coding agents, right? And coding agents are making it even easier for developers to open new PRs. And so what's happening is, as an open source maintainer, if you put yourself in the shoes of that maintainer, he's seeing more and more PRs, but he doesn't have enough help to kind of review those PRs and merge those PRs or comment on those PRs and kind of get them to the point where they can be merged into the code base. And so this is a kind of another problem that we see where the CI infrastructure and the maintainers are finding it difficult to manage. And so we have this kind of thesis, right? Your CI pipelines are your software factory, right? They're what's getting your code out the door in the hands of the people who are supposed to get it. But there are problems with that pipeline. It's slow, it's hard to debug. There's just a lot of pressure on it and a lot of pressure on the people maintaining it. And so, coming back to a point I made like a couple of slides earlier, you've got coding agents which are making it easier for people to open those pull requests. So how about if we also use AI and agents to kind of take the pressure off the maintainers, right? To kind of make it easier in some way for the maintainers to review and manage those PRs. And so we have this term, right? Agentic CI. What is agentic CI? Very simply, there's a definition. Very simple. Is CI enhanced with agents, right? What does that mean? What would those agents do? So there are a couple of examples here, right? If you have a set of coding standards in your project and you have community members opening pull requests, very often those pull requests are not meeting your coding standards. Maybe because the people didn't understand them, ignored them or whatever. And so a lot of maintainer time and effort is going into kind of doing very granular code edits, very granular code comments, saying, hey, this doesn't meet the coding standard. Why are you doing it this way? We want you to do it in a certain way. So an agent could actually read those coding standards and review a PR against them and do some of that kind of very low-level analysis. Another example is vulnerabilities. So if you have, for example, your project has a Docker file, you can have an agent actually review that Docker file on an ongoing basis and say, hey, we are using an image which is, 3 years old. It has a bunch of security problems with it. Why don't you actually upgrade? And the agent will give you a suggestion for how you could upgrade that Docker file and bring it up to spec. And diagnosing test failures, right? A lot of times when a PR is open, you're running tests, and you're seeing that those tests are failing, and it's often up to the maintainer to analyze those failures and understand what went wrong, and provide commentary to the developer, open them to say, okay, these tests are failing and you need to fix X, Y, and Z to make them pass. But that's something an agent can do. In fact, the demo that I'm going to show you in a little while is actually an example of this last suggestion. So how do we actually do this, right? Like this sounds really interesting, agentic CI, CI enhanced with agents. How would you go about implementing it? And my proposal in this talk is to use a tool called Dagger. Fair warning, I work with Dagger, so obviously I'm going to talk about it a little bit. But what is it? It's an open source project. And what it does is it's a tool. It's a CLI that you would use to create software delivery workflows. And it provides you with a programmable container engine. And this gives you a couple of different things. So it gives you a container engine so you can run all your workflows in containers. Because they're running in containers, those workflows will run the same way in any environment. So if I create a CI workflow with Dagger, I would run it locally on my laptop. It would run in a certain way. And I would take that same workflow and I'd run it in CI or run it on a cloud server. And because the entire workflow is containerized, it's guaranteed to run exactly the same way. So that takes away the problem that we saw earlier, which is the works on my machine problem. Because if the CI passes on your local laptop, you're guaranteed it's going to pass everywhere else that you run it as well. It's programmable. Programmable in the sense that you're not writing YAML, you're not writing bash scripts, you're not writing makefiles. What you're actually doing is programming the pipeline using a proper programming language. And we have SDKs for Python, TypeScript, Java, PHP, and Go. So what you're actually doing is if you're writing the pipeline in the same language that you're writing your application, which has obviously, it's much easier because you don't have to learn a different dialect, you don't have to learn a different language. You're kind of meeting the developer where he is. He's writing code in a language that he's already familiar with. Not only that, he can use his regular IDE. He gets code hints, he gets auto completion, he gets all of that stuff. So it makes it a lot easier to write that pipeline. You can use familiar debugging tools that you're already using for your application. Because it's a Dagger pipeline is just a regular Go or Python program, you can actually even use packages from your programming language ecosystem. So for example, let's say your Dagger pipeline needs to upload a built binary to Amazon S3. You can actually import that Amazon S3 library for your language into your code, just like you would import normal package, and use it as part of your pipeline. So it gives you access to an entire ecosystem of packages which are already available, tested, supported, and you can just very easily use them. And what we added recently, this is something that a feature I added recently, is that we allowed you to integrate LLMs into your Dagger workflows. And so what that means is that all those things that I just talked about, you can actually integrate an LLM, and an LLM can use those functions that you write and work with them. So how do you actually use it? So the way Dagger works is you will encapsulate your workflow. So let's say you have a large workflow, which is, let's take a CI workflow as an example. You're going to build your code, you're going to test your code, you're going to publish maybe a container of your code or a binary of your code. So with Dagger, you would break those up into independent functions. So you would have a build function, a test function, publish function, all of those things. And you would write program code in each of those functions. And you would package these together in what we call a module. And a module is basically a shareable component which other people can reuse. So if you are writing code for building a Go application, and other teams in your organization are also building Go applications, they can use your module. Maybe they have improvements to suggest, they can improve it, and everyone can kind of get the benefit of those improvements. The last thing to mention is that Dagger is actually created by the same people who created Docker. So it's very heavily, there's deep engineering knowledge of containers and so on behind it. So just going back to kind of the 4 problems, just to recap a little bit. So we talked about the works on my laptop problem, and Dagger solves it with containerized workflows, which work consistently everywhere. We talked about the migration problem. And what happens with Dagger is that your workflows are expressed in code. They're not expressed in YAML. So if you're switching from one provider to another, you don't need to learn a different provider's dialect of YAML or put in a lot of effort in that migration, because you will simply call a Dagger function. You will just trigger it in a different way, but you're calling the same function. And the function encapsulates all the business logic you need for your workflow. As I mentioned earlier, we also have SDKs for different languages. So there are 5, and there are more on the way as well. If you remember the screenshot I had earlier of the very complex CI pipeline, with Dagger, you get detailed observability of your workflow as it's running. So you can actually see exactly what is happening. We also have a cloud service, which is called Dagger Cloud, which lets you view your workflow running in an online dashboard. And that makes it easy for you to share the results of a workflow run with people in your team. So for example, if a workflow run fails, you can share it with someone just by giving them a URL and saying, check out this, try and debug it. It's a completely online dashboard that you can use. It also shows you, for example, the performance, so you can see how long a particular workflow run takes, and you can optimize and try and reduce the amount of time it takes. Too many PRs to review. That was also one of the problems that we've seen. And as I mentioned, what we have is we have LLM integration now, so you can actually add an agent into your software workflow. The bindings that we provide are vendor agnostic, so you can use it with any vendor. We support all the usual suspects, Claude, OpenAI, Google, and all the rest of them. And when you write a Dagger function and you give it to an agent, the agent is actually able to use all the functions in your module. So for example, if you have functions to build and test and lint your code, and you give that module to an agent, the agent is able to actually use those as though they are tools available to the agent. And we'll see an example of this very soon. So I'm going to do a quick demo right now of a self-healing pipeline, which is a kind of the topic of this talk. But before that, I just want to explain what is a self-healing pipeline. I've got a small flow chart over there. So we start with the developer pushing code, and he's pushing it to a repository. And what happens there is that in this example pipeline, we're running some tests. And if the tests pass, obviously it's all good. We go to the next stage, which might be creating a container and publishing it somewhere. But if the tests fail, what happens is we trigger an agent, and we give that agent the output of those test failures. And then the agent kind of enters a loop. It's going to keep trying to update the code and running the tests. And it's going to do this until the tests pass. And then when the tests pass, obviously it kind of exits the loop and it goes to the next stage. So what I've got here is I'm going to just go through a demo now. So this is a very simple REST API that I've built, and it's actually written in Python. And what it does is it gives you a single API endpoint, which lets you add, delete, and edit books in an online library. And this is it has a bunch of tests as well. And we just look through the data model for a second. I just want to check, is that visible to everyone? Do I need to make it larger? Yes? Okay, cool. So let's have a quick look at this. So here I have the data model for this API. And as I mentioned, it's pretty simple. We've just got 3 fields there, right? There's an ID, a title, and an author. And we also have over here a bunch of tests. I'm not going to go through this in detail, but basically we are just testing, creating a record, getting all the records, deleting, editing a record, and so on. And what I've done is I've created a Dagger module as well over here. And what I'm going to do now is before I get into the details of how the module works, let's actually just try to run the self-healing pipeline and see what happens. And so what I'm going to do is I'm going to put myself in the shoes of a developer. Okay, I'm a junior developer. I've just maybe just kind of decided to contribute to this project. Because I'm not really super knowledgeable. I've decided, well, what I want to start with is I want to add a field to this data model, right? And I see it already has title and author. Let's add a publisher field, right? And so edit this. And so I have added my code, and I'm going to just open a pull request. And so as you saw, there was some tests, right? And as you can imagine, I've added a field to a data model, but I've not updated anything else in this code. So those tests, when they run, are obviously going to fail. And we're going to see if the agent, which is already set up over here, is going to intervene and try and fix the problem. So while that is happening, you'll see actually over here, we're running the tests at the moment, but I'll drop into my code editor. And you can and just kind of show you a little bit of what's happening behind the scenes here. So this is the same. This is just want to check again. Is this visible, or do I need to make it larger? People at the back, all good? Cool. All right. So this is basically a Dagger module that I've written, and it has a bunch of functions in it. So let's go right to the top, and we see that I have a function here which creates an environment. And how does it work? So what we've done here is we're using the Dagger Python SDK, and we're creating a Python environment over here. We are starting with a Python-based container. We are adding some code to it. We are running pip install to get all the dependencies in. And that returns a container which contains both the code and the dependencies all ready to go. We also have a test function, and this is the test function that you saw running a minute ago in GitHub Actions. And what this is doing is it's creating an ephemeral service, a Postgres service over here. And then after it creates the Postgres service, it's actually running PyTest to run the tests, because the tests are going to run against the ephemeral service that we've created. And depending on what happens with PyTest, it's going to either return the output or the error. And as I said, we should see the tests have failed, right? You can see where the tests have failed. And now a new function has been triggered. And that function is called fix. And that fix function is the self-healing magic that should happen. So let's take a look at the fix function. Let's go back to the code here. And we will show you over here, we have a fix function. And this fix function actually has two parts to it. We say if we are giving it a repository, a ref, and a token, we want to do a GitHub fix, and otherwise it's a local fix. And why is there a difference? I'll explain that separately. So let's have a look at the fix GitHub function, which it's calling. And this is what we're doing first is we're creating an environment for the agent. This is the agent environment that we're creating. And we're saying we're giving it a before and after. And we're also asking it, we're saying before, we're giving you a workspace with the source code. It has the source code, it has the test, it has all of this stuff in it. And we want you to give me back at the end of it the same workspace with the code modifications that the agent has made. And we also want a summary of what did it actually do. And we're also giving it a prompt, right? Because we all love prompts. So let's have a look at the prompt. This is the prompt that I've produced for the agent. You can read it, but basically it's saying, hey, you're an expert Python programmer. Here are some failing tests. Please fix the tests. There are tools available to you that you can use, and make sure that you make the changes to the workspace that you're getting. And you keep doing this until the test runs are successful. So we're giving all of this data to the agent, and we're making it run a loop. This is the work loop, where it's taking the environment and the prompt, and it's going to just do agentic things over here. And once it's done, it's going to produce for us a summary. It's going to produce a diff. And it's going to open a pull request to my pull request with its suggested changes. Let's see how far along we got. Okay, it did. So let's see. It opened a pull request. It also wrote a comment, right? And this is what it did. Hope you guys can read it back, but basically it fixed the other files, which the original developer should have fixed, but he didn't. So it fixed the repository, it fixed the tests, it made sure that the tests are running, and it was also nice enough to give me a diff, so I can see exactly what it changed. But not only did it give me a diff, but it actually opened a pull request for me, which has the same stuff in it. So I can look at this pull request, and it says, hey, this fixes the pull request that the developer made. The human made a mistake, but here I'm fixing it for you. And here's a list of the changes. And so I, as the developer, I'm getting feedback. I'm getting a pull request. All I need to do is look at it and say, okay, I like this. Let me merge it in and merge it into my pull request. And now the tests which were failing earlier will pass. And then it's now up to the maintainer of the project, or the project lead, if it's a company project. That person can then decide, all right, we've kind of gone over the initial threshold, right? The coding standards are being met, security scan is being met, tests are passing. Now I can decide whether this pull request is actually useful and worth merging into the main code base. Just to also show how that worked in GitHub. So I will show you the GitHub workflow file, because that's, I think, the missing piece that I didn't cover earlier. So this is the GitHub workflow that you just saw running. It checks out the code. It runs test. And this is the Dagger function that we're running, the test function. And then it runs fix. You see there's an if condition here. If the tests fail and it's a pull request, call the fix function. And fix is then the Dagger function that you saw, which is the agentic loop, which does all the changes to the code, running tests, opening a pull request, and so on. Yeah, so that's the talk on self-healing pipelines. I would encourage you to, if you're interested in learning more about Dagger, learning more about agentic CI and agentic CI workflows, I have some QR codes and some links over there. So we are, it's an open source project. We have a Discord, so feel free to join the Discord if you're not sure if you can actually use it for your project. Drop in, ask us a question. We are very happy to help. Our entire team is working on that. There's a quick start which you can try out, and the example app that you just saw. Since we have a few minutes, I'll show you a couple more things which are also interesting. I want to show you Dagger Cloud, which is our cloud dashboard, and you can actually see what was actually happening while that pull request and the agent was running. So Dagger Cloud, as I mentioned earlier, is our online dashboard where you can view your workflows. And this is actually Dagger's own dashboard. So you can see this is our team members working on pull requests, working on our open source repository in real time. And you see it's split into two. There are local traces, which are workflows running on developers' local laptops, and CI traces, which are traces running in our GitHub Actions. So I'm going to just try and find the one I did, which is this one. And you can go into this, and let's have a look at what happened when we tried to fix it. And just to mention, Dagger Cloud is actually a free service for individual users. If you're a company that wants to use it, we have an enterprise plan. But if you're just an individual hobbyist or just trying it out for the first time, it's free for you to try. So this is actually what happened in our Dagger function. And you can see the prompt that was given to the agent. And the agent is now thinking and seeing what methods are available, right? So it sees, for example, there are methods here to read a file, write a file, run tests, all of these things. And then it starts using these functions as tools. So it's reading the code, it's running the tests, and it can see that the tests have actually failed over here. And so it has all this output now, which is the Python PyTest output. We just skip through this quickly, and it's going to now try a few different things. It says, okay, so it's already detected, for example, in this block, that the publisher field is missing from other parts of the code. And so it's reading the test file now, and it's figured out, okay, well, I need to add this publisher field, and I need to update other sections of the code. And so it's now entering this kind of agentic loop where it's running the tests, iterating on its code, and trying to come up with improvements. And we can, at the end of it, as you saw it actually was able to get the test running. It opened a pull request, and it also it added a comment. The other thing that we could look at is, as I mentioned at the beginning, because these workflows are containerized, they run the same way locally as in CI. So you just saw it running in CI. And what I'm going to do now is I'm going to try to do the same thing, but on my local laptop, and we see how that works. And so what I've done is this is the same repository, and I've made a change to the code, and I can run here Dagger call test, and this should run the tests, and we'll see it actually running on the same workflow running on my laptop over here. Make it a bit larger. So so as you can see, the PyTest failed because of the fact that we haven't updated anything else. But now the same function that I called in CI, I can actually call locally. And in this case, because it's running locally, I can't actually open a pull request. I can't have it post a comment. Instead, what I would like it to do is to actually make the changes to the code and give them back to me in my local repository here. And so what I'm doing is I'm calling Dagger call fix, but I'm giving it a slightly different, kind of different call, where I'm saying after you fix it, give me the directory from the containerized workflow with the changes and export it to my local host over here. And this is the same workflow that you saw running over there, and we'll see the prompt, and the agent is going to try and read those files and make changes to it. I have to say that this kind of demo is always a little, you don't really know which way it'll go, because I've had cases where the agent, in attempting to fix it, has just deleted my code and found that the test passed and believes that that's a good result. So that may happen. Yeah, go ahead.
So can this agent have like QA oversight over it?
So, sorry, can you repeat that?
So within an enterprise environment, you usually have your QA team. Let's say they might be separate from your team.
Yes.
And you have multiple repositories. You have multiple of these repos. Do you have some way of how we can have one team managing multiple of these QA agents, let's say, across other repositories?
So the way this is structured is that this is a Dagger module which I've written, which is specific to this repository. So the way, if you suppose you had multiple repositories and you wanted to run a similar agent, and we're assuming that the same prompt will work for all of them. So for example, they are all Python apps, for example. So you could share this module. We can share it on some. We have it's a Git repository, so you can share it, and other repositories that can use it just as I'm using it over here. So it would be a common module, and you could have a QA team or whoever, a single person kind of managing the prompt and managing the agent in that module. And obviously you could also, if you wanted, set up different prompts for different scenarios. So it is possible to do that. So I don't know if you guys kept an eye on this over here in the corner, but I actually only changed one file, and now we see there are two, and the second change has been made by the agent. And you can see what it's done is it's actually updated my book repository with some changes. We don't know if they work yet, but we can check. And so I'm going to run the test function again, and if the agent did it right, then we should see all the tests pass where earlier they were failing. The interesting thing about this is that, as I said, it's not only is it running locally, but it's also running quite fast. So if you're a developer working on this, you could, run these commands quite quickly. The agent will do the work, and you can, see the changes immediately in your repository. You can decide if you want to commit them and so on. And it did pass. Well done. It didn't actually delete the code I wrote. It tried to improve it. So kudos to the agent in this case. So the code that what I've written here is called a Dagger module, and if you write a Dagger module, it is we provide a service called the Daggerverse, and the Daggerverse is an index of all available Dagger modules written by people in our community. There are modules for many different scenarios and different use cases. I'm just going to pop up the screen so you can have a look. So just going to scroll down this so you can see the kinds of modules that are available. This is daggerverse.dev is the website where you can use these. And what you can do is, if you find a module that is useful for you, you can import it into your repository and just use it. And the instructions for doing this are, I'm not going to get into details here, but we have very extensive documentation which shows you how you can install modules, use modules, access them from your code and so on. Yeah?
Can I use this without Dagger Cloud?
Yes, Dagger Cloud is an optional service.
And the second thing, does this easily integrate within GitHub Enterprise?
I don't use GitHub Enterprise myself, but if it uses GitHub Actions, yes, it should work. We have actually, as I showed you, let me come back to this. So if you look at this GitHub Actions for workflow file, if you see, there's actually nothing very complicated here, right? We're checking out the code, we're calling a test function, and we're calling a fix function. That's pretty much it. All the business logic or what happens when you want to run tests or when you want to run the agentic workflow is all encapsulated separately in a Dagger module. Written in this case using the Python SDK. Now, if you imagine that you wanted to switch from example tomorrow to let's say Azure CI, or you wanted to switch to Circle CI or any of those, all you would really need to do is change how these functions are triggered. Like you just need to change the trigger, but you're still calling the same function. You don't need to rewrite the business logic because the business logic is encapsulated in the module. So maybe this is the syntax to run a test function using GitHub Actions. Maybe in Circle CI, it's a different way of doing it, but you just do Dagger call test or Dagger call whatever your function is, and the logic will work the same way. Yes?
Yeah, seeing that you guys added MCP support to it, how does that work? Use cases?
So we recently added, what we actually added is tool calling. And what that means is that if you can write these functions in a Dagger module, and the agent will be able to call those functions as though they were regular tools, just like how an agent can call other tools. We are still working on kind of full MCP support. There's we actually update our documentation as and when we make those improvements. So it's kind of an ongoing process of how we are approaching it. We also have another tool which I can just pop up here, which is called container use. I don't know if you have seen that tool.
I just saw it, but I didn't.
Okay, so container use is basically built on top of Dagger, and it's a tool that gives coding agents sandbox environments. So for example, in this case, my agent is making changes directly on my host, right? I'm exporting the changes to the host. And if you have a coding agent, you give it a task, it's working on your live repository. But depending on how well behaved that agent is, how intelligent that agent is, the changes that it makes to your live repository may not always be satisfactory. So what container use does is it gives that agent a sandbox environment. So it can do whatever it wants inside that sandbox. You can review what its output is, and you can decide if you want to merge it into your code base or not. But until you actually decide that you would like to merge this, it stays in its sandbox. Your live code is not actually affected in any way. You can actually spin up multiple agent environments. So for example, you could say, taking API as an example, you could have one environment where you tell the agent, I'd like to add an endpoint. You have another environment where you tell the agent, I'd like to update the data model and add X, Y, Z fields to it. You have a third environment where you say, I'd like to build a front end. And so you have these different environments, each isolated from each other, operating in parallel. And container use is giving you kind of an interface to manage these different environments.
So it works with Claude and Gemini CLI and all that?
Yes, it works with all coding agents. So I can pop it up here as well so that people are aware of it. So this is container use. And I'll just mention, since you're asking about agent integration, so we have instructions for using it with Claude, Amazon Developer, Cursor, Windsurf, GitHub Copilot, and so on. Yeah, I'm happy to answer more questions. If you have anything else you'd like me to. Yeah,
How do you control how much time it will try to fix the code?
It's a good question. Because the amount of, it's also how many tokens it's consuming, right? Because the longer it goes on, the more it's kind of eating into your wallet. You have to kind of just give it the right prompts usually. It's a matter of prompting it. And for example, you could say, well, if you don't succeed after, 10 minutes, maybe you should stop and, ask the human to help you or something like that. In this case, it's quite a simple problem that I've given it. So it does, maybe 2 or 3 loops, and then it kind of comes to the solution.
Follow-up question. Any particular model which worked best in our experience?
Well, I've tried this with many different models. I think in this particular one, it's using OpenAI, but I've also tried it with Claude Sonnet, and it works. It works pretty much. It gives you the same result most of the time. But I know that there are different, depending on the actual project and the problem that you're giving it. There may be other models which are more specialized and suited for that. But our LLM integration is, as I said, it's vendor agnostic. So you could use it with any. Even with local models or with any of the cloud APIs.
On the deployment side, on the CD side, is there anything that you have?
So basically, Dagger is a tool to create software delivery workflows. We have focused on CI at the moment, but you could also build a CD workflow if you wanted to. Like I myself had built some time ago a module which takes my build container and deploys it to Google Cloud Run. So it's very doable. And usually what happens is most of the, like if you're deploying to a cloud provider, they have usually libraries or packages and so on. So it's quite easy to add that into your Dagger workflow. So after you build the container, you can import that cloud provider's specific package and just kind of continue using their API to publish that container and configure the cloud infra and all the rest of that. So I have, as I said, if you'd like after the talk, I can show you the Google Cloud Run module that I've written, and you'll get a quick idea of how it works.